Got it. Okay, so what we could do with this phone class is we could turn around and we could make a copy of the phone class, and we'll just change it to, I should have done that to begin with. Instead of copy of phone, we'll call it cell phone. Okay. And then we could come along and we could say, well, it's basically the same thing as we had. Here's cell phone. We'll go in here and we'll add in private int plan minutes, and then we'll go down here and we'll do public int get plan minutes. Etc. Okay, and start on this cell phone class. Okay.
Initialize the variables.
Yeah. I'm going to destroy this in a moment. Okay, so there's the start of the cell phone class. It's going to mutate and it's going to do something different. But notice that we really started out with most of the phone class in here. We've got all of those variables. We've got the toString. All of this stuff is basically all the same. We're just going to add to it. Okay. Well, here's the sneakiness. Let's just save that. And let's go back to deleting cell phone. And let's start and try making a brand new one. In this case, and now I'm going to make cell phone here and make sure I put it in the right place. Should have selected that beforehand. There's my cell phone class. Now, I'm going to do something sneaky here. I'm going to go into cell phone and I'm going to say extends phone. Okay? And in this case, this means cell phone gets all of the stuff we already had. That's all there is to it. Okay? And ignore the error for a moment. So what I'm going to do in here is I'm going to only go and I'm going to put in the extra stuff, which was plan minutes. Oops. And I'm going to write the same thing we had before, public int get plan minutes to return plan minutes. Okay, and now I've got this nasty little error message. It's really because I haven't written a constructor. And a cell phone would still take in basically the same information that a phone did to start with. So I'm just going to copy that stuff into here. And the other piece of information that a cell phone takes is the plan minutes coming in. And so my constructor, if I can get to it, look at that and it'll fix it in a moment, needs to say plan minutes and I'm still going to ignore that error for a second. Okay. So what I've done here is I've said cell phone adds to the existing phone stuff. I made a cell phone that took in just a little bit of extra information and I initialized it. And the other bit of trickiness is that what I'm going to do here is I'm going to call the phone constructor and I'm going to give it the name and the number. Don't worry about the error yet, not quite there, but there's the idea that I'm just going to take in, I'm just going to write this class to have the extra stuff. I'm going to have gathered all of the phone stuff together already somewhere, and now because it's there, I can call the phone constructor and say, hey, you take care of initializing those variables that you've got, and then I'm just going to add to with the extra stuff. Okay, still with me? Now I have to get rid of the error. It turns out that the Java syntax for this, much as I would like to say phone, that's not the word that you get to use here. There's a generic word here, which is super. Means exactly the same thing. Anytime you see super in this class, just go back up and look at that word and replace it, and that's exactly what you get. It's the phone class's constructor that's being called.
You can only extend one class then?
You can only go up one level. Okay, so you can only go up to, in this case, the parent phone class.
So you can have multiple parents?
Well, so now let's watch what happens in the driver. Now what I can do is I can come along and I can say cell phone, other phone is a new cell phone that's for somebody else. And now it's got 200 minutes on their plan. Okay, and now let's just run this thing with the debugger. Let it be our friend here and see if we can figure out what's happening with this thing. I'm going to do a step over, and then I'm going to step into cell phone, and oh darn, you get stuck in something that you don't like. If I'm lucky, I can just do a step return and another step into. There we go. Okay. And so notice that what happened is that we're now in the cell phone constructor, and it's about to do this call, another step into, and we're now inside the phones constructor. Okay, so we just drop down a level. We're doing the initialization for everything that's in phone, and when we're done with this thing, we're going to go back to the cell phone constructor and finish off our initialization.
Can you initialize things like out of order, like say you're...
You have to do it in this order.
Yeah.
Basically, the rule becomes what we're going to do is we're going to get all of the other variables above us initialized, and then we're going to take care of our stuff. And some languages might allow you to do it in a different order, but that's still probably the best order. Let me take care of all this other stuff, and then I'll do mine afterwards. Okay. Well, let's just go look here in the driver class. Here's other phone, and if I use the IDE and I go other phone dot, notice that I get all of the other methods from the phone class listed because I'm adding to the ones that are already in phone, so I get not only phone stuff, but there's plan minutes, my stuff. Okay? So the bottom line of this whole thing is that when you say cell phone extends other phone, that's adds to, you get all of the stuff that phone has already got as the base stuff that you start with, and you can move on from there. Okay, so this will still work. I can go back to the driver and I can do other phone dot get name, still works. Okay, and it'll print out, here's the SAM. Okay, what if I do just other phone? What's that going to give me?
It'll give you the two-string
It'll give me the two-string from where?
phone.
From the phone class in this case, because cell phone doesn't have a two-string, but phone has a two-string. And so there's phone's two-string. When you run the driver program, there's phone's two-string printed out. But notice it's missing some information. Because why?
Because phone doesn't have planned minutes.
Phone doesn't have planned minutes. It has no way of knowing that somebody's added to it. That's the stuff that's taken care of in cell phone.
Is that what the extends object comes in by?
Well, no, we haven't got to that yet. So what we could do here is we could do, here's our friend at override, meaning I want to override an existing two-string. What is it like there? Oh yeah, I just haven't returned anything yet. We would normally say, let's make a variable and let's send it back. Now, two choices here. One choice is that I could call phones getters, since I own them. So I could call, actually, you could, to be clear, you could say super dot get name to add the name. You can also probably say just get name because you still own it. The super is just being clear as to where it's coming from, but it's already a part of you. Or the other alternative is to do what?
Call phone's two-string and then add to it.
Yeah, call phone's two-string. So we'll say result is actually super dot two-string. Go get whatever phone string had, and then we'll just tack on to it plan minutes. And send that back as a result, so that now when you go and run this thing, you get all the correct information now with the 200 planned minutes. Okay, so the whole idea here is we save a lot of work. We're back to what we keep saying about copy and paste. It's not your friend because you end up duplicating a whole bunch of stuff. So all of a sudden we've said, well, we were about to do the same thing for cell phone that we did for phone, so why not just do it this way? Okay, except you could play some games with this. For instance, we could make, well, actually we'll leave that. You could do something in here to say, am I over the number of minutes, right, that my plan had? So I have a Boolean that returns true or false to say whether you're over. So this is all adding to the existing one, right? Extends is adding to. Okay. Let's take it one step farther. Any other type of phones that are on the market? The one they give little kids so that they don't run over their time?
Prepaid.
The prepaid phone, right? So we could turn around and we could write another class prepaid phone, and prepaid phone needs to add to what?
Cell phone.
Cell phone, because it's specifically a kind of cell phone. Okay, so now we'll get all of the stuff that was in cell phone, and I'm just going to go steal, we need this constructor, right? That's the one that we have to call. So I'm going to make my prepaid phone constructor. And one of the first things that I'm going to do is I'm going to have it call that thing, which means I need all of that stuff in there. So we're going to call cell phone with a name, a number, and plan minutes, except that's not really cell phone, that's our friend what?
Super.
Super.
And you have the capital P in paid.
Oh, okay. I guess we should make them the same. It doesn't like now. Oh, sure. Someplace or other. Missing something still. One of those, maybe. I'm making it worse, aren't I?
That's a cell phone into the constructor.
Oh. Thanks. There we go. And now I probably need one less of those. And I'll run source format for a second just to make it beautiful. Okay. So if we go into our driver program here for a second, and let's do an actual example of making a prepaid phone. Steal some of this. So maybe Sam gets a burner phone. And this is a prepaid. Okay. Except prepaid phones don't come with time on them to start with. How much time do they come with? If you buy a prepaid phone,
You get to choose how much.
you get to choose. So basically it comes with nothing to start with. Because what you would do probably is you would do something like this. And then you would turn around and you would do burner phone dot by minutes. Oops. Immediately afterwards, say, please add 200 minutes to my empty phone. Okay. Well, that means the prepaid phone takes only 2 arguments. So I'm going to go back to prepaid phone, and I need to get rid of plan minutes because a prepaid phone doesn't really have any plan minutes. But then what do I pass to cell phone?
0.
A 0. Okay. And now this thing has public int, or sorry, private. This is, I guess it's still planned minutes, isn't it? That's interesting. That's fine. So when you go and you, in the driver program,
5 minutes.
let me find it again. I called it buy minutes. So a prepaid phone, you specifically have to buy minutes. And you buy some number of minutes. What does buy minutes do?
Adds minutes to for the phone.
What does the phone, what does the cell phone have?
5 minutes.
It has plan minutes. So I guess we need a setter here. So you can change your plan minutes. And set plan minutes just says plan minutes to that, so that now a prepaid phone can come along when somebody says buy minutes, and it can say, just to be clear, super dot set plan minutes
And then you want more minutes.
to that value, more minutes. Okay. Except what happens to your minutes when you talk on a prepaid phone? They don't go up,
Yeah, they go down.
they go down. You use them up until it hits 0, and then you can't talk anymore. So minutes here needs to go down so when somebody does talk, so we'll override public void talk that comes from one of the other classes, and they say int some number of minutes, then plan minutes needs to go down. We can do that the sort of the long way. So we could say, give me plan minutes, and then we could say current minutes minus equals however much they talked, and then put that back into set plan minutes. Okay, so just go get the value out, decrease it, put it back in. And now all of a sudden, we've totally changed the behavior of talk. Talk now actually ticks downwards rather than the original phones both ticked upwards when people talked. Okay, does that example make sense? It
One problem with buy minutes though, in that when you buy minutes, it resets it.
yeah, it's not quite perfect, but I just want people to get the idea of the sorts of things that you can do here. Okay. This thing is in the business of object-oriented programming. This is called inheritance, because you inherit all of the variables and all of the methods from the previous class. So extend is adds to or inherit all of the existing stuff, plus I get to be my own person and do whatever extra things I want. Okay? And that's basically all there is to it. Okay? And the phone example is probably one of the better examples that I've managed to come up with of how you would actually use it, okay? Because most people exactly understand how this stuff works, okay? Now the question is, why would you use it over some of the other stuff we've been doing? What circumstance makes it appropriate? And the easy rule is anytime that you can look at something like we did and go, well, this thing that I'm about to write is just a special case of something I've got already, then maybe it makes sense to borrow all of this other stuff and just add a little bit of my special case to change it, which is basically what we've done. So the Englishy words are actually cell phone is a kind of phone. Right? So anytime you find yourself saying it is a kind of phone, it's a special kind of phone, then typically that means that inheritance is probably going to work for you. Okay? How often does it actually happen in real life programming? Surprisingly little. But when it does, it happens very, very frequently. So for instance, the graphics classes make fairly heavy use of this stuff. So if you remember the example I did way back when with the little GUI I gave you, it was the GUI, my GUI extends JFrame, and that gave me all of the graphic stuff that had the closed box and all of the basic outline of the graphic window built in. So I didn't have to write that code. So I got all that stuff for free, and then I got to extend, add to it to get the stuff that I really wanted to put in there. Okay? So there's a few places, graphics is one of them where you see it an awful lot, but one of the problems with it is that it actually doesn't appear all that much. And I'll point out that you can discover that by going and looking at all of the object-oriented textbooks from the last 20 years, and almost all of them use only two examples. The traditional examples are bank accounts, right? You start out with a standard bank account, and you can have a savings account that's a special kind of banking account that gives you more interest, but it's basically got all of the same information as a bank account, right? So you see that one a lot. The other example you see is they always start out in the textbooks with the mammals, the animal hierarchy. So you've got your mammals, and then below that you've got your beavers, which are a special type of mammal, or actually rodents, I guess, which are a special type of mammal, and then beavers, which are a special type of rodent, etc. Right? And so they say, well, here's that inheritance hierarchy where you get the same properties, and then you modify those properties as you become more specialized. Okay? Two examples, you go look in books and you go, oh, I need a different example. I didn't really understand that one. You open up a computer science textbook, and I pretty much guarantee you it's either bank account or mammals. Right? And this phone one is probably the only other sort of small usable one that I've seen that people naturally get and go, okay, it makes sense. Should you use it all the time? Probably not. What will tend to happen with these things is that sometime when you try to make stuff special, you find yourself going through more and more antics to try and go, oh, well, it's sort of the same, but it's different. Like, we're already in trouble with talk because we've made it sort of work totally differently than it ever worked before. And sometimes if you find yourself really starting to mess about, it's easier to just split things up and go, well, I know it has a lot of the same information, but it is actually different enough that I'm just going to treat it totally different and not worry about it. Okay? So there's no real specific rule about it other than it starts out easy and then you start to squirm and you go, okay, maybe I'll do this differently. Okay? But you're always trying to, if you can, make use of some code that's already there in a reasonable sort of way. Okay? Let's talk about one more thing that you can do with this. We had a little issue here with this thing because we had to write getters and setters in order to access that thing, because this class really isn't any different than any other class. It still doesn't have access to the variables that are in those other classes directly. There is a way that you can give the variables access. You can go into cell phone, and instead of marking this thing as private, you can turn around and you can mark it as protected. And protected says people who inherit from me can use this thing. And that gives you the ability in here to just go current minutes or plan minutes. Do it this way, minus equals however many minutes. Okay, and notice that now works because I'm saying any class that extends from me has access to that variable. The regular people don't, but if you're a special kind, then you can do that directly. Code looks a lot nicer. It's a lot cleaner. Just go grab the variable and change it. Good idea or not?
Depends on how you want to use it.
Seems like a good idea. The advantage is that it was a lot easier to do. What's the disadvantage?
You can't control whether or not someone has access to the variable.
Yeah, as soon as you mark it as protected, you lose control over that variable because the classes that follow on no longer have to use the get and the set. And if your primary reason for writing the get and set was to maintain control, you've now just lost control. That makes sense in some cases, but the example I always use is think of teenagers at home when they first get their driver's license, right? They're part of the family, so they've inherited the car from the family. So technically speaking, they shouldn't have to ask for it. We could mark the car as being protected, which means anybody in the household can go grab the keys and drive the car. But what do parents usually do with a new teenage driver? They don't say, oh, here's the keys, go use it whenever you want. They say, now hold it here. You have to still, if you want the keys, you have to ask for them, just like anybody who was not a member of the family in the outside world would have to do, because I want control over whether or not I give you the keys and what you're doing with this car. Okay? So yeah, technically speaking, you should be allowed to do that. But you might run into problems by giving away the keys to the car, and so maybe it's better to maintain the control. Okay? Again, there's no right answer to that. It's obviously more convenient to just say, oh, here, go use it. And there's some presumption that the people who are inheriting from you already know how the family works and are less likely to do bad things because they also own this, right, than other people would do. But, you know, the parents in this case have definitely lost control. Okay? So I tend to favor not saying protected and just letting people use the getters and setters as appropriate, and that puts all of the control in one place for doing whatever needs to be done. And that's it. We'll do another example of inheritance tomorrow just to get the idea.